So in the previous session, we have seen the collect operation and we saw how we can use collect operation to combine multiple data together so that we can decrease the number of rows, which will be more better because there is no meaning of having a lot of rows and whose data is completely meaningless. So now with this, our next topic comes into the picture, which we will start from today. Just open the table. Types of internal tables. How do we declare a internal table at this moment? Like this way, right? Like this way. This is how we declare it. What kind of internal table is this one? What kind of internal table? So we are required to understand types of internal table. How many types of internal table are there? So in our ABAP programming, what you are going to see is we have got three types. So we have three types of internal table in ABAP programming, out of which the first one is standard internal table. Then we have the second one, which is sorted internal table. And then we have got the third one, which is hashed internal table. Standard, internal, sorted, and hashed internal table. So what are the differences between them and how we are going to use based on the different kind of requirement? So let's start with our standard internal table, and they are, what you are going to see here is they are also known as default internal table. Default internal tables. Let me open the server so that we can see it more clearly. I will go for log on. So of internal tables, create understanding types of internal tables, and I will go for type executable. I will assign the package and the transport request. So let's create a structure, simple structure for our employee ID. So begin of ty employee ID, empid type data element of employee ID and employee name, type data element of employee name. Pretty simple, just a structure of two columns. So employee ty employee. Then how do we define an internal table? This is how I define it. LT employee type table of ty employee. And then maybe I define a work area. So type ty employee. This is how we define a internal table or work area. So we have three types of internal table: standard, sorted, hashed internal table. Standard internal table are also known as default internal table. That is, whatever internal table that we had created or we have created till now is nothing but a default internal table. You can either define in this way or you can define it like this way. Let's say lt underscore emp type standard table of ty employee. Same thing, no difference. Either you can write this way or you can write this way. Both of them are default internal tables, no difference. This is the first point. Second point, they are index based internal table. Internal table. That is that is every record will have a index in database. So using read operation, we can directly get the data based on index. That is why they are index based internal tables. Okay. Then third point, append statement, or let's say here we can records can be inserted or appended. Both records can be inserted or appended. Now, what is the difference between insert and append statement? Anybody?
The insert can be done above any of the fields in the table, but the append of a record is only done at the end of the internal table.
Yes. Simple difference. Append statement, it inserts the records only at the last of the internal table. It inserts the records only at the last of the internal table. And we have insert statement. So insert statement. How does insert statement works? So insert statement inserts the records anywhere, guys, anywhere in the internal table, at any place. We can insert it at any place. That is why insert statement. Now let's see how we are going to use them. So for that, I will store some data. Let's comment this thing. I'll store some data. So ls employee, I'm going to store an employee ID. Employee ID is equal to 101. Then what I will do, I will store employee name. Employee name is equal to, let's say, Shivam Singh. Now I'll append ls employee to work area, which is lt employee, and clear ls employee. One record has been inserted, appended. So let's just copy it and let's insert two more records. So 103, and here I'm inserting 104 record. Now just see what is going to happen here. Then I am going for again, and this time I am going for, let's say, 102. Where does 102 record will be now? At which index?
4.
Yes, 4. So if I display data into the end loop, if I display data using write statement, ls employee ID, ls employee name, if I display it, I am going to get it at the fourth index. I'm going to get it at the fourth index. Very, very perfect. But is this the correct way? No, my 102 must be at the second index. It should be in sorted order. So how am I going to do that? How am I going to do that? So what you are going to see here is, for insert statement, we have got two ways. Two ways to insert the data. We have got two ways to insert the data. First one is, what we can do, that instead of this one, we can use directly insert here. So insert your work area name, which is ls employee, into your internal name, index number 2. Okay, let's check for the syntax. Yes, it is working, and execute it. Can you see? By default, it will insert the data. By default, it will insert the data. Now just see what is going to happen if I am not going to write in this way. I am writing a different syntax for the same approach. So insert ls employee into lt employee, or let's say into table lt employee this time. This is the second approach. One is directly passing the index, another is directly inserting into the internal table. Now let's see how it is going to work. Execute. It is still coming at the same position, right? It is still coming at the same position. So two ways are there for performing the insert operation. If you are not specifying the index, at which the data should be stored, by default your data will be stored at the last one. It will become the append statement. Two different syntaxes. Okay, two different syntaxes for insert and for insert statement. Okay, so let's comment it out and let's uncomment this one again. This is our third operation of my default internal table. Fourth, data is by default not sorted. Not sorted. We can sort the data. Can sort the data, right? We have also seen it already. Sort lt employee by your column name on the basis of which you want to sort. Activate it and execute it. Perfect, right? I am sorting my data. So sort operation we can perform. This is my fourth point. Then we have fifth one. Let's see. Fifth one is, for standard internal table, we can read the data based on the key and based on the index also. We can read the data based on the key and based on the index also. That is, we can read the data based on a key or primary key. So what else we can do? Read table my employee name into work area name with key employee ID is equal to, let's say, 101, and then if size sub rc equals to 0, what we can do? What else we can do? We can display the data. Comment the below code. Check for this one. If there is a 101 data in my internal table, this should execute and it should give me some result. Yes, it is giving me. So one is this one, and the another way is we can also perform. Let's copy this thing, comment it, and we can also perform the index one, that is index 2. Activate, execute, index 2. So we can perform the read operation for our standard internal table based on key and based on index also. So this one is another thing. Then the next point, for standard internal table, we can use the linear search as well as we can also use the binary search, right? Binary search. We can also use the binary search. We can also use the linear search. By default, this guy is going to perform the linear search, but you can also perform the binary search. For binary search, there is no need of index. We will always go for a key part. So we can also perform the binary search. By default, the complexity of the binary search is really less if you compare with the linear search or any other searching technique, and that is why binary search is more preferable. You will get the data more easily, like a million times faster. As your data is already sorted, you can directly perform the binary search. So both of the searching technique is allowed. Both of the searching technique is allowed in case of your standard internal table. This is your standard internal table. We can also write one more point: response time. Response time depends upon the number of entries in the internal table. Response time depends upon the number of entries in the internal table. This is the concept of your standard. Now let's see the sorted one. Any doubt in standard internal table?
No.
Okay. Then we have sorted internal table. So sorted internal table are a type of internal tables in which by default all the data is sorted. By default all the data is sorted. So we need to specify a we need to specify the key while declaring the sorted internal table. If I have to display the sorted internal table, or I have to use this concept of sorted internal table, I will need to specify the key while declaring the sorted internal table, so that based on that by default my data can be sorted. Based on that by default my data can be sorted. Now let's see how we are going to define. So let's comment this thing and let's define here. So data lt employee type sorted table of ty employee, type sorted table of ty employee unique key with unique key employee id. Okay, unique key employee id. Wait, there is some error in line 16. Okay, in line 44, no issue. Let's just comment the line 44 code. Yeah, now let's see if there is some issue. No. This is how we are going to declare our sorted internal table with our key. Based on that, by default your data will be sorted. Based on that, by default your data will be sorted. Okay. And
Mhm.
third point, we should not use append statement for sorted internal table. Instead, we should go for insert statement only. Can anybody comment on this? Why should we not use the append statement inside our sorted internal table? Instead, we should only go for insert statement. Can anybody comment on this? Why? Think on that.
Because we should know if it is if after if after insertion it is still sorted. So
Mm,
if we just append it, then maybe it's not sorted anymore.
yes, that is the main reason. Because my system, the definition of your sorted internal table is by default, it must be in sorted order. So if you are following the concept of append statement, if you are following the concept of append statement instead of insert statement, just see what is the mistake going to happen here. 101 first record, 103 second record, 104 third record, and then 102 fourth record. Are they in sorted order based on this employee ID? No. So you will get a runtime error. You will get a runtime error. And if you will go into the code, can you see the same place where system is showing you the error? Never ever use, never ever use, never ever use append statement inside the, never ever use append statement inside your sorted internal table. Okay, otherwise you will get a runtime error.
Mhm.
You can all write the code that you will not get the error. It is possible. It is possible. Just comment this thing. You will not get the error. But this is not a good approach. In the real time scenario, we should never go for it, because we cannot predict where we are, any mistake that we had done, and if your code is not working in the production, your entire work is meaningless. So never ever go for it. We should only go for we should only go for insert statement. So we will go for insert ls employee into lt employee into table lt employee. By default it will store your data automatically. You don't need to worry on that. So let's copy this code and let's paste it here. Comment on this one, paste it here, and comment this one and uncomment this one. Let's check the syntaxes. No error. Activate it. Comment this read for now and uncomment the loop. Let's see I'm able to get the data or not. Execute. Yeah, it is perfectly fine. I have not specified any index. Still my 102 is coming at the second place. Because by default, based on the sorting, 102 will be stored at its own place. This is the concept of your sorted internal table. Okay. Then
Mhm.
some more points here. Data is already sorted. And therefore there is no need to use the sort statement. Then we can read the record using key or index both as a sorted internal table is also index based. Is also index based. Both of your code is going to work. You can check. Let's comment this loop, activate, execute, perfectly working. We can also go for index based also. This one, activate, execute, perfect. This one is working also. Then since data is already sorted, sorted, it is recommended to only use binary search in sorted internal table. Since data is already sorted, it is recommended to only use the concept of binary search in sorted internal table. So if you want, just go here and instead of this one, let's go for binary search. Just see here, binary search. We have already seen it, execute, and we will get our data. So we should only prefer the concept of binary search. And just see the difference here. Here we are also performing linear search. Data is coming linearly. Order of n is going to be the time complexity. In case of our binary search, order of log n is going to be the time complexity. So by default, the efficiency of your sorted internal table will be more and more as compared to the standard internal table, right?
Yes.
So response time of a sorted internal table is very fast, very is very fast as compared to the standard internal table, as compared to the standard internal table. Okay, perfect.
Mhm.
Then let's go for has internal table. Now has internal table is a special type of internal tables which works on has algorithm, algorithms. Anybody have any idea about hasing, hashed algorithms? Mukul, Alan, any idea?
No, I
No, I
just
don't
know
know.
about,
Okay, no
all I
issue.
know
It's just
is,
a one of the technique is hasing in data structures and algorithms. Okay, so they have taken this thing from there to build their own internal table which works on these algorithms. We are not going to write any algorithm for that. By default, internally it works on that, and then it returns our data. Okay, we are not going to perform anything on that. We will just define our internal table. So how we are going to define it? In the same way, as we have defined our sorted internal table. So lt employee type has internal table of or has table of ty employee with unique key is also necessary here. So unique key employee id. Okay, pretty simple. Now, what is hazing? You might be thinking on that if this is working on hash algorithm, what is hazing? Hazing is hazing. So in SAP, let's go for only SAP. We should not need to learn about something else. So in SAP, hazing is a technique. Hazing is a technique which directly returns the the address of the record based on the search key, which directly returns the address of the record based on the search key. So let's say now you know directly the address of each element. Okay, so will you be following linear search or binary search now? Is there any necessity for it? If I directly know that my item is stored in a particular box and I know its location, will I go and ask some other person where is my item? No, I will directly go to that box and I will take my item, right? So
Yes.
if I know, just think on that. If I have items like this way, if I have elements like this way, and I know that my item is at this particular position, why should I start from there? Why should I go for linear search, or why should I go for the middle element to go for binary search? I will directly go for this position, right? I will directly go for this position as I know its location. I have the address of my record. This is how your hashing techniques works. It returns the address of the record based upon the search key. Whatever key you are going to search, it will directly return the address. Don't go the complexity of it, guys, that how it is returning you. But we need to know that this is how hashing works. It directly returns the address of it. And once we have the address of it, my job is done. I can get the data and perform whatever thing I'm looking for, right?
Yes. Hmm.
So, second point, as the internal tables do not support the concept of indexes. They do not support the concept of indexes. That is why they are that is why they are not the index based internal table. This is the difference between internal index based internal table. This is the difference between your sorted, standard, and has internal table. Sorted and standard are index based, but your has is not index based because it do not support the concept of indexes. There is no meaning of indexes in has internal table. We all have the address of each element. We have the address of each and every element here. So we can directly perform these things. Now, third point. As internal tables, as internal tables, has internal table is do not support the append statement. It do not support the append statement. If you are going to use here append instead of sort, you are going to get syntax error. Simply syntax error. Can you see? Syntax error. It do not support the concept of append. It only supports the concept of insert. Oh, can you see binary search? It is also giving us error, right?
Hmm.
Searching is only for the index based kind of thing. If you are performing binary search, the primary condition for binary search is your data must be sorted, your internal table must be in sorted order, right? But is there
Yes.
any meaning of getting sorting in case of your has internal table? No. No
No.
meaning of it. So there is no need of binary search. I can directly get my data. There is no meaning of binary search here. So append is not supported here. We only go for insert statement. We only go for insert statement. If you will go for append, by default you are going to get the compile time error. Then fourth, there is no impact of sort operation. There is no meaning of sort operation here. So there is no impact of sort operation as we read the data based on the hashed algorithm. Based on the hashed algorithms. Then next thing, we read a data using key. Index is not supported here. Since they are not the index based internal table, there is no meaning of it. There is no meaning of it. If you will use here, if you are going for index, you will get error. You are going to get a error, compile time error. Explicit or implicit index operation cannot be used on tables with type has table. Never ever use it. Never ever use it. Otherwise you will get error. Otherwise you will get error. I hope this thing is clear. Okay. Here has algorithm is used to search a record. Now my question is, which is more efficient? Which one is more efficient? Think on that and tell me which one is more efficient.
I think the hashed internal table
Okay.
for
What about you,
searching.
Mukul?
I was also saying the hash internal table, but
Okay.
yeah, for example, I don't know why what's the purpose of using a hash internal table, but I could think of this scenario where we have the employee IDs 101, 102, 103, where they will be the key, and then it's easier to find the employee.
See, here we are getting data directly based on hashing, right? Directly getting the data based on hashing techniques. We have the direct address. It doesn't matter if you have million records or whatever records. If you have the address, you are directly going for it. We are not directly going for like this one, this item, just looking for it, that if I am able to find it or not. If I am able to find it or not, till then I will just go for next and next. So if I have the direct address, I will directly go and find it. So there is no meaning of how many data is there. So what you are going to see, here, response time is faster as compared to standard and sorted internal table. Very fast. As now there will be a reason. So as response time is independent of number of entries, doesn't matter how many entries are there, because we have the address, I can directly get and that. So where it is well suited, so it is well suited for table. It is well suited for table where we have a huge number of records and we want to search based upon unique key. Okay, is this thing clear?
Yes.
This is your types of internal table. Now there will be a question that which internal table we should prefer. So the simple answer for this one is totally depends upon the developer. Totally depends upon the developer. But everything has some pros and cons. So the only developer will be responsible for this thing, right? It totally depends upon the developer what kind of internal table he or she is going to use for the projects or for the any developing any product. So it totally depends on him or her who is using it. Okay. So this is your types of internal table. And if there is no doubt, let's move on to next topic.
Just one question.
Yeah.
So these tables are only defined on the application layer, not on the
They
database layer.
are temporary internal tables. That is why they are internal table. They are temporary tables. Okay.
Yeah.
Only for storing temporary data to perform certain kind of actions, right?
Okay, so for example, if the table is already existing on the database and it is not sorted, it is not the sorted type. But if you want to define the internal table for that table,
You can then define
sorted
it.
type, will that work?
Definitely. How you are going to do it? Whenever you define an internal table, what is the necessity for it? We need a structure, right? We need a structure. You will define a structure for it, na? If you don't want to define, you will always need a structure, right? So this is the meaning of it. There is no meaning of any table here. We are going to bring data from DOM and then we will store them in this internal table. So that is why there is always a lot of complexity with this has internal table. So if we want, like if you are performing most of the you have like lots of data, then my personal suggestion with my experience will be go for sorted internal table. But I mostly go for the standard one only because it is easy to manipulate it. While coding, it is easy to maintain this thing. That is why I go for it. But again, I wanted you must know both of them. There can be requirement while you whenever you will be developing any project. Okay.
Okay. Good.